If we want to find the angle bisector of the angle that two straight lines form when they meet out of the boundaries of our paper, which is our case now, you see that lines R and S meet out of our boundaries, we have to apply the definition of angle bisector, which is that an angle bisector is the straight line whose points are equidistant or at the same distance to the lines that form the angle. In order to draw any line, we need 2 points, so we need to find 2 points that are at the same distance from lines R and S. Let's begin with the first point. We'll draw a parallel line whose distance is the same to straight R and to straight S. First, we choose a random point on straight line R. We draw a perpendicular line to straight line R that goes to point 1. This one. And we do the same with any other random point on straight line S, for example point 2, and we draw a perpendicular line in relation to line S that goes through point 2. The one I'm drawing now. This one. Now, if I take the same distance on these lines, we will find 2 points that are the same distance, each one from both lines. This first point, point 1, is at a certain distance to line R, and this point 2 is exactly at the same distance to line S than point 1 is to line R. If we draw a parallel line to line S that goes through point 2, and I repeat the operation, drawing a parallel line in relation to line R that goes through point 1, we have 2 parallel lines, each of one is at the same distance to each line. So these lines S and R are at the same distance to lines R and S, so the point where they meet, this point A, is at the same distance to lines R and S at the same time. This point, as it at the same distance to lines R and S, belongs to the angle bisector of the angle that lines R and S form. I'm going to repeat the same operation with another point. For example, point 3 on line R, we will draw a perpendicular line in relation to line R that goes through point 3. This one. And now I draw another perpendicular line in relation to line S through one of its points, for example, point 4. I draw a perpendicular line in relation to line S that goes through point 4. Now I will take the same distance on these perpendicular lines and a different distance than I took before in points 1 and 2. For example, this distance and the same from point 4. Point 3 and point 4 is at the same distance to each lines R and S. I draw a parallel line in relation to line S that goes through point 4, and I draw a parallel line in relation to line R that goes through point 3. R and S meet at this point B, which is at the same time at the same distance to lines R and S. If A belongs to the angle bisector and B belongs to the angle bisector because both are at the same distance to both lines, the line that goes through both points will be the angle bisector of the angle that R and S form. Line V.